Morning, children. Yesterday we were already started the discussion with respect to the competitive part of the 7th chapter, that is evolution. In that one we were already discussed about the few questions. Today we will continue with respect to the competitive part. Okay, so few more questions we will continue with respect to the competitive part. Okay, yeah. So in that one, first question. So this question is also related to the topic origin of the life. So which theory is known as the primary abiogenesis? So before we are going to discuss about the options, let me to tell you briefly. So theory of abiogenesis is also known as theory of spontaneous generation. It was put forth by Greek philosopher and was supported by Aristotle. So this theory was supported by von Helmont in 1642. It believed that the life originated from non-living material spontaneously and continuously. Okay, and they believed that the elements like air, water, fire, and the earth have vital force, reactive principle to transform the lifeless matter into the living things. So in short form, we can also say that it is nothing but the chemical evolution. Okay, so this is about the theory of abiogenesis. Okay, so which theory is known as the primary abiogenesis? That is nothing but chemical evolution. Okay, so now you can identify which is the right option. Option C is the right option for the first question. Okay, yeah. The next question, this is also related to the origin of the life. So in what way Urey and Miller created a similar condition of primitive earth in their experiments? So here, while we are discussing about the Urey-Miller experiment, I told you clearly how they were conducted actually experiment, isn't it? Let me to tell you once again briefly. In 1953, Stanley Miller and Harold Urey, okay, from the University of the Chicago, designed an electric discharge closed flask experiment. That is nothing but simulating primitive atmosphere. Okay, it is nothing but replica of the primitive atmosphere using an apparatus. So this experiment is evidence in the support of the chemical evolution of the life. Okay, and here, so how they designed actually. So Miller designed a glass apparatus called a spark discharging apparatus. The air from the apparatus was removed by using the vacuum cork and it's sterile. The mixture of the gases like methane, ammonia and hydrogen were taken in the ratio of 1:2, 2:2 in the spark discharging chamber, isn't it? So that you can easily identify which is the right option. Yeah, they made an electric discharge in a closed flask containing the mixture of methane, ammonia and hydrogen, okay, and the water vapor. So that is nothing but 800 degrees centigrade temperature. Okay, yeah. So this is the right answer. Which is the right answer? Option A is the right option with respect to the Miller's experiment. Okay, the next experiment, so the next question, it is related to the evidences for evolution. So let me to read the question. Read the following statements regarding the study of the fossils in the different sedimentary rock layers. So that is, it is related to the paleontological evidences, isn't it? Yeah. The first, the statement, fossils in the lowest layers are of simple organisms. The second statement, Mesozoic era is the age of mammals and angiosperms. And the third statement, life forms varied over a time. The fourth statement, certain life forms are restricted to certain geological time spans. So whenever you read all these questions, the statements, out of this one, The second statement is false because Mesozoic era is called Age of Reptiles, or it is also known as the Golden Age of the Reptiles, not Age of the Mammals, isn't it? That's why second statement is wrong. The first one is also correct, third one is also correct, and in fourth statement is also correct. Okay, now you can identify which is the right option. Yes, option B is the right option for the, so that means the, so this third question. Okay, yeah. The next question, this is also related to the evidences for evolution. Analogy is due to, yes, in the last class also while we were discussing about the homologous and analogous organs, I told you clearly what is the meaning of the analogous organs and the analogy. The organs whose structure or origin is not similar but functionally same, hence they exhibit convergent evolution, isn't it? The phenomena is called analogy. Okay, how they actually forms, yeah, so this is nothing but a becoming of unrelated species more similar to adopt in similar environmental condition. Because whenever you see the examples, then you can come to know examples. The wings of bird and butterfly are not anatomically similar, but they perform the similar function, that is a flight adaptation, isn't it? Hence the analogous structures are a result of convergent evolution. Another example for analogy is the eye of the octopus and mammals, isn't it? The flippers of penguin and dolphins. So these are all some of the examples. Okay, you can give for the analogy or the analogous organs. Did you got it? Yeah. The next question, evidences for evolution. This is also related to the, among the following statements, pick out the wrong statements. See here, you should identify, first of all, let me to read the options, then you can identify. So out of these four statements, one statement is false or the wrong, remaining all correct. Okay, yeah. Option A, tubers of Solanum tuberosum and Pomea batatas are analogous organs. Yes, because tubers of Solanum tuberosum is, that is nothing but potato is a undergone stem modification, and Infomia batatas is nothing but taproot modification, but still they perform the similar function, the storage of the food and water. So yes, that is a true. Okay, then second option, human's hand, the whales of flippos, cheetah's foot, bat's wing contains almost the same bones, muscles, blood vessels, nerves. Yes, so these are all the best example for the homologous organs, isn't it? They shows the divergent evolution. So what about the option C? Yes, seals flippos, bat's wing, horse foot, cat's paw, human hand are example for analogy. Wrong. Okay, actually these are all the example for homology or homologous organs. They were given the analogy, so that's why option C is the right option but wrong statement. Did you got it? Then the D is correct. Wings of the insects are from a thin flap of the chitin, and the wings of the birds are modified forelimbs. Okay, so out of these four statements, option C is the wrong statement and a right option. The next question, evidences for evolution. Again, the Darwin's finches, Australian marsupials, and Australian placental mammals are example of. Yes, that is nothing but both B and C, adoptive radiation and divergent evolution. You know very well that while we are discussing about the adoptive radiation, I told you clearly. Okay, so how they're adopted. First of all, let me to recall once again adoptive radiation. What is adoptive radiation? The evolution of different species in a given geographical area starting from its original character and radiating to other geographical area is called adoptive radiation, isn't it? What about the divergent evolution? Yes, so that is nothing but the homologous organs, the organs whose structures or origin is same but functionally different, hence they exhibit divergent evolution. Okay, so this divergent evolution and these structures are homologous. Okay, homology indicates a common that is ancestry. Did you got it? So that's why option D is the right answer. Okay, so that is both B and C, both adoptive radiation and divergent evolution. Did you got it? Yeah, the Darwin finches, Australian marsupials and the Australian placental mammals are the best example. Did you got it? Yes. The next question. So these are also related to the evidences for evolution. Given below are some facts related to natural selection. Identify the incorrect fact. So here also, so let me to read the statements one by one, then you should identify incorrect one. Sooty areas give great protection to the melanized moths. Yes, it's correct. Penicillin triggers the synthesis of resistance proteins that produces penicillin resistant varieties in bacteria. So this is incorrect with respect to the natural selection. So here we should consider the Darwin's principle. Based on that we should identify, that is based on the natural selection we should identify the statements. Okay, yeah. And the other one, so taking full course of the antibiotics as prescribed can prevent the development of the antibiotic resistant varieties. Yes, it's correct. So that's why generally a good physician, so generally is prescribed as to take the complete course of the a particular antibiotics or the medicines. The industrial mechanism can be considered as an example for the directional selection. Yes, that is also correct. Evolution is a stochastic process based on the chance events in nature and the chance of mutation. That is also correct. Okay, out of these 5 statements, option B is the incorrect with respect to the natural selection. Okay, you know what is natural selection, right? Yeah, so that is a Darwin theory of evolution, the theory of natural selection. So that is nothing but it is a process of selection of better adapted individuals with useful variations by the nature. Are individuals less adapted to the environment are eliminated and selecting those better adapted by the nature. So this is called natural selection. So this is popularly called Darwin theory of the evolution. Okay, yeah. So the next question, so this is related to the Hardy-Weinberg Principle. So let us recall once again. So what is Hardy-Weinberg Principle? It is related to the genetic equilibrium. Gene frequency remains constant from generation to generation unless it is altered by the external agencies, is called genetic equilibrium. Okay, and this law was proposed in 1908 by G.H. Hardy, a British mathematician and a German physician, isn't it? The German physicist E. Weinberg. Okay, so the law attempt to establish a connection between evolution and gene frequencies. Since evolution depends on change in the gene frequency, they put forward a formula P plus Q is equal to 1 or 100% to calculate the gene frequency, isn't it? Yeah, so this is about the Hardy-Weinberg principle. But here in this question what they were given actually, in a diploid that is a 2n. Small m and small n are the frequencies of alleles, represents capital A and small a respectively. Then the total frequency is, so this is just like, so while we write the Hardy-Weinberg principle, p plus q whole square is equal to p square plus 2pq plus q square, right? Like that here it's also small m square plus 2mn plus n square is equal to 1. Okay, so where, so this is nothing but the 1 and second, so that means it is same as it is. Okay, if you write down the p plus q whole square, what we will get? P square plus 2pq plus q square, right? Like that here it's also, instead of p you should write a small m, and instead of q you should write small n. Then it will be like that, m square plus 2mn plus n square is equal to 1. So according to, so this Hardy-Weinberg principle, so both, so that is a 1 and second. Okay, the Hardy-Weinberg principle, just now I told now how to calculate. See, consider here only they were given by adding, so that is nothing but according to p plus q whole square is equal to p square plus 2pq plus q square. If you know the values already, then you substitute. Okay, here only they were given in a population Hardy-Weinberg equilibrium allele frequency of capital B, that is nothing but capital B, one they were given is 0.85. Then the frequency of capital B small b, so while we are discussing the percentage of the terms with respect to small p and small q as after the completely, so that is p plus q is equal to 1 or 100%. So if you want to identify the small b, you just subtract the value of the, so capital B in 100, then it's easy, you will get 0.25. So which is the most appropriate answer among these four options? Yes, 0.25. Okay, because if you add this to 0.85, you have to get it. Okay, so among these one, you cannot say always exact one, most appropriate or nearest to value you should identify. Okay, yeah. So this is also a question related to the Hardy-Weinberg principle. False statement related with Hardy-Weinberg equilibrium. So evolution is a departure from Hardy-Weinberg equilibrium. Yes, it is a true. Then option B, allele frequencies in a population are stable and constant from generation to in the absence of other evolutionary influences. Yes, that is also true. It cannot be used to determine the time and degree of evolutionary change. False. It can be used to determine the time and degree of the evolutionary changes, isn't it? But here they were given it cannot be. So that's why option C is the right option, but false statement. So the other one is correct only. Reshuffling of the gene combinations during crossing over affect Hardy-Weinberg equilibrium. So these are all it is the statements it is related to the Hardy-Weinberg principle. Okay, yeah. So the next question, this is also related to the Hardy-Weinberg principle only. Okay, so while we are discussing Hardy-Weinberg principle, we will also discuss the agents of evolutionary agents, and also there are 5 factors known to affect the Hardy-Weinberg equilibrium, isn't it? So that is a gene flow, genetic drift, mutation, genetic recombination, natural selection. And here what they were given actually in this question, in an area, it is application question actually, in an area of a black rocks and the white rocks, black colored rabbits and the white colored rabbits can be hide from the predators, but gray colored rabbits cannot hide in their environment and suffer greater predation. So this kind of the natural selection is known as disruptive. Okay, so while we are discussing in the theory, it is clearly we were discussed. Okay, so how generally, okay, the species they protect from the environmental camouflages, isn't it? So based on the so during the predation, what will happen, how it will be picked by the predators if the organism cannot hide, okay, cannot hide or cannot camouflage with respect to their surrounding environment. So then those organisms can be easily picked. Okay, so this can also be, so we can also explain the evidences for natural selection. While we are discussing about the industrial melanism, we were discussed how the moth species of Biston betullaria and Biston carbonaria. Okay, so as it is, if you compare the same the topic or the example, then you can get it. So this is nothing but, so this kind of natural selection is nothing but disruptive selection. Okay, the next question, brief account of evolution. Yes, which one is mismatching? See, out of these are 4 options, the beginning 3 is correct. Jurassic, herbaceous, lycopods, ferns, conifers, cycads, these all comes under the Jurassic only. In the Cretaceous era, yes, Siphnoid, that is a Syphnopsids, Horsatiles, Ginkgos, Nitales, Dicotyledons, these are all found in the Cretaceous period only. Mesozoic era, again dinosaurs and ichthyosaurus, but tertiary, yes, is a mismatch. Okay, so it's a mismatch. The monkeys Homo habilis and Homo erectus, they were not found in the tertiary, isn't it? Did you got it? Actually in quaternary we found that a modern man, early man, so isn't it? In tertiary we found the large carnivores, first abundant grazing mammals, large running mammals, isn't it? These are all. So that's why option 4 is the right option, but wrong. Okay, there's a mismatching. So the last question, the brief account of evolution. So which of the following human race started to use the hides to protect their body and buried area? So this is one of the important characteristic feature with respect to geological time scale. Okay, modern man. So generally while we are discussing a particular species or the race, isn't it, the origin and evolution of the man. So from the beginning, so ancestral ape, so that is a Diapithecus and a Ramapithecus, and the ape man Australopithecus, and primitive man Homo habilis, Homo erectus, and Netherland, that is a Neanderthal man. Modern man, so that is a Homo sapiens, again a Cro-Magnon and Homo sapiens. Out of these the races, so they were given on the important statement, that is nothing but which of the following human race started to use hides to protect their body and buried dead. Yes, that is nothing but that is a Homo neanderthalensis. So these fossils were collected from the Netherlands Valley of the Germany with a brain size of 1400 cc cubic centimeter, lived in the East and Central Asia between 1 lakh to 40,000 years back in Central East and Central Asia. So they used to hides to protect their body and buried their dead ones. This is one of the important characteristic feature with respect to the, so that is a Neanderthal man. So they are also known as a Homo neanderthalensis. Okay, so these are all with respect to the about the chapter evolution. So let it be. Whenever it comes to the direct contact, the physical classes, we will discuss few more questions which is related to these questions. Until then, you just go through it, all these things. If you have any still doubts, please let me know so that I can clarify your doubts and we will continue the further topics. Thank you. Have a nice day.